Hello again and welcome to DMA 30 section 3.8. This is the first part of a two-part series discussing solving percent problems using percent equations and proportions. In this video we're going to cover percent equations. So we're going to learn how to translate a percent sentence to a percent equation and then how to solve to find an amount, then a percent, and finally a base. In the next video, we're going to cover the same things, but with a different method. It's the percent proportions method. So we'll talk about the formulas for those proportions that we'll use, and then solve for an amount, a percent, and a base again. So when we want to translate a percent sentence into an equation, there are some keywords that we have to look for. First of all, the is. We might remember this from algebra, is always going to equate to the equal sign. So when we find is, that's where we're going to insert an equal sign. Of, which typically mean times, translates to multiplication that is shown with a raised dot. Okay, we don't use the x because we'll get that confused with our variables. And the phrase is what number or what percent translates to an unknown number that is represented with a variable. Okay, so let's translate this sentence right here. What number is 33% of 80? Okay, so what number is going to be our unknown? We're going to represent that with the variable x. Is going to be the equal sign. 33% we're going to represent as a decimal. We always want to represent these percents as a decimal of, let's see, is going to be multiplication that we'll show with the dot, and then 80 we'll just write as a number of 80. Okay, so that sentence, what number is 33% of 80, is going to look like x equals 0.33 times 80. Another way that we can write percent sentences is by using these formulas here. There are two different ways to express these. Either the amount equals the percent times the base, or the part equals the percent times the whole. Remember, again, when we're plugging in percents, we always want to express that percent as a decimal. So we'll use this example here to see what this will look like when we use a percent equation. I prefer to think of it as the part equals the percent times the whole. Okay? So our percent is given to us, that's known, that's 0.36. Okay. The whole here is going to be the 400, 36% of 400. That means 400 is the entire population. So that's going to be the whole. And our part is the what number. That's what we're solving for. So that's going to be our x. Okay. So we can also, if we know which part is the whole, which part is the part, which one is the percent, we can use these percent equations to translate percent sentences into formulas as well. Alright, now we're going to do a couple of practice problems where we're solving to find the amount, okay, or the part. So what number is 84% of 500? What number, we'll represent with x, is equals 84%, 0.84 as a decimal, of means times 500. Alright, this problem's pretty straightforward. When we're solving for the parts, our variables is left alone on the left, and the constants are on the right. We just have to do this multiplication, 0.84 times 500, and we get 420. Example 2. What number is 240% of 80.3? Okay, what number? X is equals 240%. We need to move the decimal in two places. Is 2.4 times 80.3. Again, our variable is left alone on the left. We just have to do the multiplication. 0.4 times 80.3, and we get 192.72. In these two examples, our percent is going to be the unknown represented with a variable, so we'll be solving for the percent in these. Now keep in mind that when we solve these, it's going to give us our answer in a decimal, but we want to convert that decimal to a percent to express our final answer by moving the decimal 2 places to the right. So, example 1, 4 is what percent of x? So 4 is equals what percent? That's x of is times 80. Okay, so we have 4 equals x times 80. To get x by itself, we need to do the opposite of the operations that are affecting x. So right now it's being multiplied by 80. The opposite of that would be to divide by 80. So I have to do that to both sides. Divide the left and the right by 80. X divided by, or 80x divided by 80 is just going to leave me with x. Okay, and 4 divided by 80 is going to be 0.05. But remember, I want to express that as a percent, so I move the decimal 2 places to the right, and I get x equals 5%. Example 2, 5 is what percent of 8.5? So 5 is what percent? X of 8.5. Again, to isolate x, I'm going to divide both sides by 8.5. Those will cancel and I'll be left with x. And then 5 divided by 8.5 is, I'm going to round this to 0.588. Okay, when I express that decimal as a percent, move that decimal in 2 places, I'm going to get x is approximately, since I rounded, 58.8%. Last but not least, we're going to solve percent equations to find a base. So let's look at example 1. 3 is 5% as a decimal is 0.05 of what number will be represented with our variable x. Again, to isolate x, I'm going to divide both sides by the coefficient of x, which is 0.05. That will cancel. And I'll divide by 0.05 over here. I'm left with x on the right, and 3 divided by 0.05 will give me 60. No need to convert here because I was solving for a number, not a percent. We only need to convert when we're solving for percents. Alright, example 2 is a little trickier. 150 is 66 and 2/3% of what number? Now, if it asked me for a rounded answer, I could express 66 and 2/3% as a rounded decimal, maybe 66.67, but it doesn't ask for an estimated or a rounded answer. So I'm going to take this a step further and show you how to solve for the exact answer. Before we do that, 66 and 2/3% looks like what? We can express this as an improper fraction. Do 66 times 3 plus the 2 and get 200 over 3%. But remember, I have to convert my percents to decimals, and I do that by dividing by 100, right? So I need to divide that by 100 and get rid of the percent sign. 200 thirds divided by 100 is the same as multiplying by the reciprocal of 100 over 1. So that would be 1 times 1 over 100. Okay. And I'll divide by the common factor of 100. I'm left with 2 up here and 1 down here. And when I multiply, I get 2/3. So you may remember this from the chart from an earlier video, but 66 and 2/3% is equal to the fraction 2/3. So that's what I'm going to use instead of the decimal 0.667, 0.66 repeating in my percent equation. So when I translate this, I get 150 is 66 and 2/3%, I'm going to write that as the fraction 2/3 of what number? X. Now, to solve this, I could divide by 3/2, but remember that dividing by a fraction is the same as multiplying by the reciprocal, 3/2. So I'm going to multiply by the reciprocal on both sides of that fractional coefficient. Let's look at 150/1. Now what happens here? The 3 and 3 cancel, the 2 and 2 cancel. I'm left with just x. Okay, and now I can multiply over here. 150 times 3 is 450, and 2 times 1 is 2, so 450 divided by 2, which is equal to 225. So our base here, the whole, is going to be 225. So remember, if they're not asking you for a rounded or an approximated answer, and you're given a mixed number like this, and it's going to be a repeating decimal, represent that instead of as an estimated or a rounded decimal as the exact fractional equivalent by finding the improper fraction, divide by 100 or multiply by 1/100, and then you should get that fraction and use that in your percent equation. So to review, in this video we talked about percent equations, translating percent sentences to percent equations, and then solving for the amount, percent, and the base. Next time we're going to do the same thing but with percent proportions. It's a different method used to solve for percents. So we'll talk about the formulas that we'll use, and then we'll solve again for amounts, percents, and bases. See you next time.